Let's try some other types of questions. So here is a sample. It is very important that you have to draw the diagram first, and I can tell you that you have to use a little bit of geometry, and it should be simple to solve afterwards. So try yourself, pause the video now. Okay, so the idea of energy is very simple here. It's just converting from mgh to half mv squared to ke. But the most tricky thing is how do we evaluate h, the change of height in this case. So you have to draw a diagram. So this is the diagram that I draw. Obviously, one thing that you should realize is the length does not change, because if the length is changing, that means it is elastic string, then the whole physics will be very complicated. So even the question didn't say so, in IB physics, or generally I think in all high school physics too, unless you are doing some very complicated syllabus, then it will be treated as inelastic. So in that case, that means it will be 1 meter here, and also it will still be 1 meter here for the whole length of string. But then in that case, since the pendulum has already been moved like this with 10 degrees, so it will be lower in that case. So you have to find out so what is the delta h. And this could be done by using geometry, and obviously you probably find out this length first, and the way that to find out this is 1 cosine, because this whole length is 1, right? So imagine this triangle, then it will be 1 cosine 10 degree. That will be the length for this part, and for delta h, then that would be simple, because that will be 1 minus this part, right? So 1 cosine 10 degree will be delta h, and so the rest will be easy. You may realize that the m is not given, so then how do we do it? But then in fact it will be cancelled out on both sides. G, actually we should know it, so let me change it to 10 or 9.81 if you like to. And so the whole equation only got one unknown remain, that is v. So you should be able to find out the value of v by using calculator. And so the answer should be 0.55122 something, right? And I should run it up to 2 SF, so 1.55 meter per second. If you find out some other numbers, like it's not like 0.55, probably the mistake would be you didn't use 10 degree in your calculator. You probably switch to radian mode or some other thing. So you may want to check that. Next question is one of my favorite questions in this question set. This is not the hardest question or the most special question, but then I would like you to try using two different approach. So that is, first of all, using the energy approach, what you learn in this subchapter, by obviously considering what kind of energy involves here, and you should be able to reach the answer. That means the speed when the ball strikes the floor. At the same time, I will also want you to try to use the kinematics approach. So that is actually this whole thing you have learned very similar situation in the last chapter in projectile motion. So you can try to use those kinematics equation to try to calculate the same thing as well. So hopefully at the end you should find the same answer. Pause the video and try it now.
Explosion.
Okay, so let's try to do the energy approach first. So from the energy approach, you see that at the beginning it would have KE and GPE. Alright, because it's moving in 4 meters per second in this direction. Actually, it doesn't really matter which direction it is, and it has a certain height above the ground, so GPE. And when the ball hits the ground, the GPE will be gone because it all converted into KE. So the equation that you will write will be GPE plus KE equal to KE. I'll use 1 and 2 to annotate to make them distinguishable. So then after you use the equation, you find out all the m will be cancelled out. So that is why the question did not tell you the mass, alright, because it doesn't matter. No matter it's 1 kg, 2 kg, 3 kg, it should be the same result, assuming that there is no air resistance. After you substitute all the known values, you'll find out that the v, which is the final speed striking onto the ground, will be 6 meters per second. Notice that this is only telling you the speed, not the velocity, because they are not the same thing. And the advantage, you may say, for energy, you can already see. I mean, I haven't talked about kinematics yet, but you can see kinematics take longer steps, while energy take only 4 lines to do it. And the only disadvantage is that for doing this, you would not be able to directly find out the velocity, so like as in the direction, and therefore that's the only thing. But therefore this question I think is good enough. In order to do the kinematics approach, let's take a look here. You have to decompose it like what we do: horizontally, vertically. And horizontally is just 4 meters per second, like what we have earlier. And for vertically, you just have to do what we do earlier, like acceleration, initial speed, and the distance, which is 1. Initial speed is 0 because it is only horizontal velocity. There's no vertical, so that's why it's 0. So you want to find out the vertical final speed at the end, final velocity at the end, I should say, and then you will combine them into a resultant velocity like this picture. Alright, and you can kind of think about Pythagoras Theorem, as in like moving this theta to this side, so you can kind of make a right angle triangle, so you can kind of measure how much it is for the resultant velocity. So after you find out the calculation using the kinematics equation, that will be 4.47 meters per second, together with the earlier from the question 4 meters per second using Pythagoras Theorem, then you'll be able to find the same result, interestingly. Alright, so I hope you find it's also quite mind-blowing as well, because this is a thing that we're proud of for physics and also mathematics, that using different approach you can find out the same result. If you're interested to find out the angle, then kinematics will be easier probably, because you can just use Vy divide Vx, and that should be the tangent theta. So you'll be able to find the angle by using the inverse function of this. Alright, so if you're interested, you can find it out yourself. But I think overall the most important thing is that probably in the exam they won't tell you which approach you should use, but both approaches would work eventually. So it's really about which way you want, and if you choose it, then probably you want to stick with it in the exam.